Hello, welcome back to Blender Sushi LiveEnoDing. In this episode, I will be recreating this setup by Celestial Maze. Actually, this is the pose he did the other day, and so it's like 1.5 minutes. You can rewatch this yourself, but I will try to recreate it here by following every steps, because this one doesn't have sound, but I kind of know what's going on, and there's a few things that I didn't know, but I watched this a few times, and okay, that's using the dot product. And you basically have you can start with a cube, and then you do like a cell fracture. Cell fracture is like an add-on or extension in Blender to make like a Voronoi fractures of 3D objects. And after you do that, after you have the fracture, you put it into collections. And then inside collection, if you bring it into geometry nodes, you can load it as instance with separate children. And then you can use scale instances and rotate instances. And then kind of using this empty, and then you did a little bit of math, comparing the position of each instance with the empty. And yeah, you get this really cool effects where you can have directions, and also you can scale down each of the instance based on the distance. So yeah, I'll probably gonna recreate that from scratch, but I just want to show you. Okay, the cool thing, of course, because this has directions, and you can animate it this way, and then you can bake the animations. And then the direction also allowing you to kind of reverse like this is kind of effects that's kind of classic, and you have seen it maybe in Transformers or something. So it's disappearing or it's like appearing. Okay, so currently I have a few collection here. The first one is this fractured cube. I have this one. The second one is the fractured monkey. So I already have the monkey being fractured inside the collections, and then it's being separated. And I have also things like, okay, let's say if you have like a building architecture, and you want to make it disappearing one by one, each components, you can do it that way. And you can also use it with a text object. As long you have text object, convert it into mesh, and then you merge mesh that's vertices that's connected together, and then you separate them, and then you set the origin. Okay, so let's actually recreate this from scratch, sort of. So you basically need collections, and inside collection you already have the fracture, and then you will need to scale and then rotate instances based on this simple math. There's also this empty. Okay, so let me try to do that. So edit preferences. With the latest Blender, you need add-on or excuse me, get extensions. And then you can search for cell fracture if you don't have this already installed. So you need to install this. You might need to do something with the system to allow online access or something. Yeah, but once you have cell fracture, you are good to go. You can use the cube or use the monkey head. Let's try the cube first. So cell fracture anim. We need to subdivide it the way this cell fracture works. You need to subdivide it basically. Let's actually use the sphere in this case, so it's gonna be slightly different, right? Apply. So we have enough subdivisions, and then F3 cell fracture. So this is the default setup. Just hit OK. You can change the presets, but you're gonna get this sphere that's already broken up. You have the original cube, and then cell fractured object. Yeah, I should have put this into collections. So M, new collections, fractured sphere. Okay, I just hide it. Let's go inside geometry nodes, create new. Oh, I will actually create news on our original objects. Make sure that's selected, new. Now we want to bring our collections with separate children turned on, bring our fractured sphere. So if we use that, we actually have this ability to just scale the instances. So we already have that kind of cool effects, right? You can actually do that. You can have random value for the scale if you want to have that kind of effects. If you switch this to EV and ray tracing, you're gonna have nice GI. Oh yeah, that's what I want to show you. So file, save as. You can randomize if that's what you want, but let's not do that. Rotate instances. This for random rotations, of course. Right? Random rotations and random scale. You can do that. So let's reset everything. We can see the crack a little bit, but don't worry. Let's use our single arrow empty. So this is going to be the directions, and then we're going to compare it with the instance here. So single arrow empty goes in. This guy have locations and also have rotations. We're going to compare it with the position of each instance object. So this is already instance objects when you bring it into geometry node. So you can vector math subtract, I think. So position and subtract with the location of this guy. Subtract it. I have to go back and have a look. Okay, position subtract vector rotate dot product. Oh yeah, there's a lot of things. Vector rotate, vector math dot product. How to explain dot product? Things comparing. Imagine there's a plane that's hidden, and then there's a rotation, and also maybe for explanation you can ask Meta AI or ask Gemini AI or ChatGPT. Yeah, what is dot product? Anyhow, so we have this vector. We need to invert it. It's using Euler, and it's comparing it with the rotation of this guy. Euler, rotation goes in. I think there's a conversion happening there. And there's a dot product, and we have a value. Value should be maybe between 0 and 1, or -1 and 1. We need to subtract the value. Subtract 1 minus this guy. Do we need to clamp it? We did clamp it and put it into scale. Yeah, I don't know why that works, but yeah, it's like magic. I don't know why it works. In the future, hopefully the AI can look at geometry nodes visually and then give a better explanation than what I'm doing here. Okay, anyhow, so subtract map range. So there's a dot product, and the dot product should be the value. It's a scalar value. Take two vectors as an input and then produces a scalar output. A and B is a vector, and you get calculate the finding the angle between two vectors. Okay, maybe anyway, I can't really explain that. So dot product should give you a scalar value that you can play around with. Map range, random value, and scale. Map range, random value, and scale. Okay. Map range, random value, scale, vector. I guess vector math. This one should be scale. This goes into the rotations. Random value maybe between minus tau divided by 2 and then tau divided by 2. And the scale, map range, dot product goes in, minimum maximums minus 0.5 to 1, minus 0.5 to 1 tau. This goes into the scale. Okay. Yeah. So we get the effects happening. Maybe this one too much. Okay. Anyhow, we got directions and we are able to scale it. Maybe I will make another video how we can actually bake it into animation so we can use it in AR, augmented reality. But that's basically the process. If you want it to be Suzanne, you start with Suzanne head and then you do the cell fracture again. Same drill. You can also use torus. Let's use monkey. Okay, monkey head. Just turn this guy into, just remesh this first. Turn it into a single object, apply, F3, cell fracture. It's gonna do the hard job for us. Turn it into 3D Voronoi fracture. Magic happening. Press M, monkey fracture, create, hide it. So we have monkey head. Just add our geometry nodes effects. This time, this needs to go out as an input. So this we can use the monkey fracture. So we can have these effects happening for us. And if you wanna have text, also text will work. And this kind of thing, if you have like a building block, architecture types, anything actually, if you get objects from Sketchfab, if you separate the objects into different parts, you can actually use these effects without any issues. Okay, so as long you put this into collections, and then each of the objects instance needs to be centered. The pivot needs to be centered. Okay, so have another object, replace this with this guy with this building. So this can be hidden now. You can do that same effects. Same thing with the text object. If you have text objects in Blender is quite special, so make sure you know that this is how it works in Blender. Let me use blend full. Write down blend full, and after you do this, okay, you can set up the smoothness, convert this into mesh, and each one of them is actually still separate. Go to edit mode, F3, merge by distance, so each objects needs to be separate but also connected. And then you go to separate by loose part, and then after you do that, you also need to set origin to geometry. So I've been hitting excuse me, hitting F3 or function 3 in Mac, and I need to center pivot the objects, put this into collection, new collections, and call it text fracture, create. So we will need to duplicate this again and change this into our text fracture. So now we can really have that effect. So these guys need to be hidden, and this is also arc fracture. It's like geometry. So you can have these effects happening for every object in the scene. Okay. Pretty simple once you understand it, but thanks to Celestial Maze. Actually, I highly recommend this if you are on Twitter X, Celestial Maze and Hixas. There's a lot of information here on the post. Highly recommend it. And yeah, something like this. It's a short video under 1.5 minutes, and you got all the visuals. It doesn't have explanations. Maybe in the future the AI will do it. In the meantime, sometimes I do this, like myself, deconstruct. You can also do this yourself, so you don't need to watch my videos in the end. But still, yeah, it's quite something. Lots of things to learn. The breakdown of certain effects like this, you can perhaps in the future modify the setup. Or in the future, maybe you can ask AI to modify the setup or kind of use different effects together with this setup, as long as you understand the basics. All right. So hopefully you find this useful. Thanks again for tuning in, and I'll see you in the next video. Thank you. Bye.